Okay, so today we're going to talk about angle pair relationships. Our first term that we're going to talk about is what they call adjacent angles. And when you see the word adjacent, I want you to think of next to, okay? Next to each other, all right? These are angles that share a common vertex and a common side, but no points that are on the interior together, okay? So notice right here, angle 1 and angle 2 would be said to be adjacent angles. And same here, they share common vertex and common side, but no common interior points, okay? So here would be your examples. Notice right here, angle 3 and this angle right here would not be adjacent angles. Right here, angle 3 and this great big angle would not be adjacent angles, okay? Our next term is what we call linear pair, and it's exactly what it's saying. Linear meaning line, and a pair meaning two angles that form a line. So here would be your example right here, angle 1 and angle 2. These two do not form a line, so that would be not an example of a linear pair. So this would be what it would look like, okay? The next thing you want to talk about or look at is vertical angles. And vertical angles are, to me, the ones that look like they form the V. Okay? So notice you've got 4 angles here. And in these 4 angles, looking at angle 1 and angle 2, they are said to be vertical angles to each other. They are across from each other. 3 and 4, they are also vertical angles. They are across from each other as well, okay? Notice that these two lines, 1 and 4, actually make up a linear pair, and so does 3 and 2, which again looks different from that one over there, okay? All right, moving on. It says identify 2 angles that form, and I'll finish reading over here, that form a linear pair. So if I'm going to name, using this figure, a linear pair, I could say PIQ, so angle PIQ, and then from that it would be what? QIS, because it has to form a line. Angle QIS. All right, the next one's asking you to name a pair of vertical angles. So vertical angles, again, I could say PIQ again. All right, and then it would be, for this one, there's the V, and then the one opposite it would be the one right underneath it. So TIS. Okay? All right, they share common vertex, but no common side. All right, here we're going to talk about some rules about them. Vertical angles are always going to be congruent to each other. So notice this angle right here is congruent to this angle down here. Likewise with these 2 angles right there. So any vertical angles are always said to be congruent to each other. Okay? Complementary angles are 2 angles whose sum is 90 degrees. Okay? They can be next to each other, adjacent angles, or they could be non-adjacent angles. Any 2 angles that add together to give you 90 degrees is going to be complementary. And one way we think of that is if I draw a little line there at the C, notice it looks like 90. Okay? Supplementary angles, these are 2 angles that add up to 180 degrees. Okay? So 3 and 4, they form a linear pair. Notice they are 180 degrees. These 2 add up to 180 degrees. Those are also supplementary angles. So remember, C comes before S, so 90 comes before 180. So if you're thinking about distinguishing between the 2, okay? I know I just mentioned it here, but our next example tells us that anytime you have a linear pair of angles, they will always be supplementary, and so that kind of gives you that justification there too. All right? So looking over here, example 2, and I'll read it, what it says from the notes. All right, example 2 says, find the measure of 2 complementary angles if one angle measures 6 degrees less than 5 times the measure of the other. 6 degrees less than 5 times. So I would say 5x minus 6 would be one of the angles. okay? Measure of angle 1, if we want to call it, okay? The measure of angle 2, that other angle, well, if it is 5 times the other one minus 6, then that other one would be called x, okay? Because in the directions it says, find the measure of 2 complementary angles if one angle is 6 degrees less than 5 times the other one, okay? So notice they are complementary angles. So together their sum is 90 degrees. So we have x plus 5x minus 6 is equal to 90. 6x minus 6 is equal to 90. If I add 6, we get 6x is equal to 96. And then when I divide by 6, we get 16. X is equal to 16. So they want us to find the measure of each angle, okay? So if angle 2 is x, then the measure of angle 2 is going to be equal to 16 degrees. And when I plug it in here, that's going to give me 5 times 16 minus 6, which gives me 74. You could, if you wanted to, say, okay, well, if this is 16, then this one has to be 90 minus 16. All right? So that would give you your 2 angles. Okay? All right. Now we're going to talk about perpendicular lines. And I know you've learned before that perpendicular lines are 2 lines that form a right angle. Okay? So what it says here, it says perpendicular lines to form right angles, intersect to form right angles. So you've got a right angle here, you've got a right angle here, a right angle here, and right angle here. They usually will only give you one red square there, okay? But that's understood that the rest of them are also 90 degrees. It says perpendicular lines intersect to form congruent adjacent angles. So in other words, if you've got this linear pair here, and this is 90 degrees, then this one's also going to be 90 degrees. Those are congruent adjacent angles. Same thing over here, 90 degrees and 90 degrees. Segments and rays can be perpendicular to lines or other line segments and rays, and the right angle symbol in the figure indicates that the lines are perpendicular. Here is our symbol for perpendicular, okay? So if I were to say this, I would say line AD is perpendicular to line CB, okay? All right, let's do another problem real fast. Okay, so this one says find x and y so that line KO and HM are perpendicular, okay? Find the measure so that KO and HM are perpendicular. So this is 90 degrees, which means this is also 90 degrees. This is 90 degrees right here, and so is this one up here, okay? So notice what we have here. We've got to find x and y. Notice where my 2 x's are, okay? Remember, together they form 90 degrees. So I would say 3x plus 6 plus 9x is equal to 90 degrees. 9 plus 3 gives me 12x, plus 6 equals 90, minus 6 minus 6, 12x equals 84. So x is equal to 7, okay? So if x is equal to 7, then I could plug it in to find out individually what these are over here. For y, remember 3y plus 6 is just that great big angle, so I would say 3y plus 6 is equal to 90. So minus 6 minus 6, 3y is equal to 84, and then when I divide by 3, I get 28. Okay? So basically, you're using the figure and what you know about it in order to answer the problems. Interpreting data, keep in mind that you can't assume anything unless it tells you. Unless you have the right angle symbol, you can't assume that you have right angles, okay? In the figure, you can't assume that things are collinear unless they're actually on the line and things like that, okay? Last question down here, determine whether the following statements can be justified below. It says the measure of angle VYT is 90 degrees. VYT is 90 degrees. Actually, you can interpret that and say it is 90 degrees because remember, here is a line. So these would actually be 2 linear pairs. So if this one's 90 degrees, then yes, that one is 90 degrees. That is true. Okay? The next one says that TYW and TYU, okay, this angle right here and this big angle right here are supplementary, okay? You can assume that. You know that this right here is 90 degrees, but you don't know what the measure is of this one. So that would be false, okay? And last, it says that VYW and TYS are adjacent angles. No, they are not adjacent. They're not next to. If we were talking about this angle right here, then that would be adjacent to this one. But these two are not adjacent to each other. They share a common interior point, which is S, so that would be false as well.